There you go. So this was a senior capstone project, which consisted of us designing and constructing a structural testing frame that will be used by future students here at the university. It's going to be more for the engineering program, the structural analysis program, but this is to test load capacity on concrete beams and other structural elements using a hydraulic jack and with sensors that are going to be put on the beams, and they're going to be measuring the flexion and strains. The final design is on the pictures, as you can see. It was a process. First, we have to do calculations of how much load we were going to be putting into our frame, how big the frame was going to be, what type of steel we were going to be using. And when it came to the type of steel we will be using, we had to calculate the load capacities of the frame, and if it will be able to resist the 10 tons that we will be applying on the frame and other loads that the frame itself is going to be carrying as well, so it doesn't break down on the students when they're using it. You can also see right here, this is what we did. We did why is it not going to the next one? Oh, there you go. You can see how we designed this in AutoCAD. We went ahead and did supports, but where the horizontal beam is at, this section right here, this is where students are going to be putting in their concrete beams, and they will be tested by the jack. That's here. These sections right here act as supports, and we designed the whole frame to be able to withstand that load that's going to be added to there. I don't know if you want to add something, Danny, about the frame.
No, because at first the frame is designed, first based on the calculations, and then we created it with a program called RFEM by Dublaw. So that gives us a 3D representation of the calculations and the structures, strengths and capabilities. And here we have an example of the results showing the stresses on the frame.
Mm-hmm. So we were able to make the frame to be able to resist those 10 tons and a little bit more, so it doesn't break down on the students. This is the final result of how it looks like. You can see the jack right here on this section. This is just a sample beam that the shop let us borrow for us to like test out the frame. It's a very small beam, nothing compared to what students are actually going to be making. But it's just a sample for us to test it out. This is the final result right here. So you can see everything. It's very big, actually. It's actually 7 feet by 12 feet long. So you can see I'm actually 5 feet tall. Danny is like around
6'3".
6'3", so you can imagine how tall this is. It is very heavy as well. But we're happy that we made this happen and for students to use and be able to put what they learn in class and do it hands-on and be able to see it in person. Instead of just having pictures and having to calculate numbers, you get to see what you are calculating in this frame. And yeah, do you have any questions?
Yeah, so what will this be used for?
What will it be used for?
Yeah.
Oh, it will be used for students to calculate stress, strain, and be able to see what is it? Shear on concrete beams. Are you in an engineering program?
No, I'm
No.
safety engineer.
Okay, yeah, so this is more of like when it comes to structures. I don't know if you've seen cracks on the buildings.
Mm-hmm.
So students are going to be able to see that on their beams. when they make big concrete beams like 10 feet long by 1 feet tall or 2 feet tall, they're going to be able to see those cracks. And then that's what they're going to be getting information, data, and be able to put it into the computer and actually understand what is it that they're learning in class. So they're applying whatever they're getting from class, they're going to be applying it here, and it's going to be vice versa, going back and forth.
Okay, wow, that's cool.
Mm-hmm.
Thank you.
You're welcome. Hello, Dr. Parker. Oh,
I got here late. I'm going to let Danny ask a question, but I want to hear the whole thing.
No, it's okay. Danny's my partner.
Oh,
Yeah, I'm
good.
the one
Okay.
who
Well, I want to hear
signed
both
this
of you.
Yes.
with Rosa.
Do you mind starting over?
Yes. Go
Okay.
ahead, Danny. I already did the first one. I was like, oh.
Okay, so this is our project we call the structural testing frame, and what we're using this for is for the upcoming mechanics of materials laboratory, and where students can use a concrete beam to test its structural properties from stresses, the flexural, and etc. So in our poster, we show different images we have made, like this one in red. That is a rendering of the structural itself. They're created in RFM, and then below that is the drawing of it created with AutoCAD. Can you show me more of the shop photos, Rosa?
Yes. So this is the AutoCAD.
Drawing.
We did have some problems when we first started. We usually didn't start off with holes being put here because we thought that the inside was going to be smaller. But when we went to go see it in person, it was humongous. It was huge. We didn't thought it was going to be that big. So we decided to make more holes to be able to adjust the bottom beam.
Adjustable.
Yes, so it's adjustable to go up and down depending how tall the concrete beams are going to be made. So this is one of the images. You can see where the jack is going to be. We made it to be able to withstand those 10 tons that is going to be applied. So the beam can be strong enough and not break down on the students. So we made our calculations good. And hopefully it goes well. Because we already did test it at the shop using a small little beam that they had right there. But so far, everything seems to be working well. As you can see, it's 7 feet by 12 feet long. It is very big and it's very heavy. It's around almost 2,300 pounds. It's huge. As you can see, I'm 5 feet tall. Danny is,
And I am 6'3".
yeah, so you can imagine how big that beam is. Any questions?
Yeah. Okay. That is amazing. And, but I love that. I think it will be safer for students, right?
Yes, we calculated it to withstand double the applied force that's going to be applied with the jack. So around 20 tons, and the jack only goes up to 10 tons.
Wow.
Mm-hmm.
And now let me ask you, now that's going to be connected, or is it going to be connected to a computer program that automates the data that you're collecting? Yes or no?
Yes, we're going to be, they're going to be applying sensors that are going to be measuring the deflections and the strains on the concrete beams. Yes.
Oh, that's excellent. Excellent.
It's going to
Now,
be very
is this
interesting.
your senior project?
Yes, this is our senior project. We have to create this out of nothing, scratch.
Wow.
Dr. Tito was like, just make sure it is 7 feet tall by 12 feet long. And I was like, oh my God. We didn't even know where to start. We were like, oh my God. And the book that we were using a lot was the Steel Construction Manual. It looks like a Bible. It is huge.
Yeah. Oh yeah.
Yeah, it's a Bible.
Well, you leave a product for the new incoming students to really learn from.
Yes. No, I feel like if I was one of the new students and this was there, it would have been very helpful because you get to see what you calculate in class. You get to see it in person.
Absolutely.
Yeah, it's a design flow. It's basically from whiteboard to the computer software, print it out on a drawing paper, and then you just have to shop and actually build it.
Wow.
Mhm.
That's great.
It's very
Great.
interesting. Very excited for the future students. I wasn't able to take advantage of this, but it's
Of
gonna be there
course.
for them, and I'll be coming over to check it out as well.
That's great.
Mhm.
All right. Thank you. I'm going to head to another session.
Okay. Thank you, Dr.
Great,
Berger.
Thank
great
you very
job.
much.
Mhm. Thank you. Do any of you guys have any questions? Andrea? Are you speaking? I cannot hear you.
Hello, can you hear me?
Yes, I can hear you now.
I was
Okay.
saying that I did miss the entire presentation, but I did notice that you guys built a hydraulic jack, it looks like.
No, not a frame to hold the hydraulic jack. The hydraulic jack is gonna be the one applying force into the concrete beams that are
Right.
gonna be made by students.
Okay,
Yeah, so this is for the structural analysis and design engineering technology program. Mhm.
which I am a part of and
You
hopefully
are?
get,
I have been seeing you around.
Oh,
yeah.
I talk to everyone and I have not seen you.
I have been so busy this semester. It's really crazy. I have like 7 courses. I
7?
have,
That is crazy.
Wow.
What year are
that
you
does
in?
include, I'm junior, but for the past 3 semesters, I've noticed have 7 classes, past 3 semesters. I'm like walking sleep right now.
No, it's okay. I understand. I remember working full time and being a full time student. It is crazy.
On
But
top of that, I have NSLS. I'm the vice president of NSLS here at UHD.
mhm.
And it's crazy because our president has been hospitalized for the past week. And so I've been acting president of NSLS. And so it's been a little tough on me, classes and everything.
Okay. But
So
you're
far, so good. So
yeah, you're doing things. You're making
I'm
changes.
doing it.
Yes. So you're part of the Scholars Academy as well, right?
Yes, I am.
And your
Yes,
SAD major, right?
Yes, I am. Yes, I
I
am.
need your information because we're looking for students to work during the summer with Dr. Tito for the as research leaders for
Mhm.
Is it NSCI or NTSI summer program?
Oh, this summer, I'm all booked up for this summer because I have an internship in Albuquerque that I'll be going to.
Oh,
So I won't
that's
even be
great.
there.
An internship. Take advantage.
Oh my God. And it's to design up there at the nuclear power plant. They want to see if I can help them with their design. So I'm like, yay.
Yes, that's
Yeah,
good. It
that's
will look great on your resume.
Oh my gosh. Who you telling? I am so excited and I can't wait till June.
No worries, girl. You got this. All right. Any other questions that you have?
Nope, I think that's everything.
All right, girl. I don't know if you want to stick around, but we have someone new, so I'll ask him if he wants to know more about this.
All righty. You have a good one.
You too.
Oh, let
Thank
me give
you.
you my information before I leave.
Okay, okay. And hello, Eric. Eric?
Yeah, hello.
Hello. So we just went over this. I'm gonna do a quick overview for you. So this was me and Danny's
Capstone project.
yes, our capstone project, our final project. And it was to design a frame that will be used by future students, engineering students here at the university. And we had to design it to withstand 10 tons and it'll be used to test concrete beams. It is 7 feet tall by 12 feet long. We first made calculations on the side on Excel to make sure what type of steel beams we will be using on the frame, the sizes, like the I or HSS. And from there, we went ahead and put all of our information into RFM to make sure it's going to work and be able to withstand that that load that's going to be added. And from there, we went ahead and put all of that information and the drawings into AutoCAD and send it off to Wellforce, a shop, to actually be created. So this is the drawing that we did on AutoCAD. It could be taken apart and be put back together. So it's going to be put on the 7th floor, hopefully. And this is just a quick view of how we put the information into RFM, and it gives us the stresses on the frame. And this is how big it is. The final product, as you can see, I'm actually 5 feet tall, Danny 6'3".
6'3".
So you can see how big and humongous this frame is. Do you have any questions?
So it's gonna be on the 7th floor?
Yes, it's gonna be for structural analysis and design engineering
In
degree.
the mechanics of material laboratory.
Also, I think it's gonna be also for senior projects that are coming up, so they could do research with concrete beams, and they're gonna be using this frame. From what I heard from Dr. Tito.
Oh, that's cool.
What major are you in?
Oh, I'm in CIET.
CIET. Oh, okay.
Yeah.
Controls instrumentation. I was gonna do that from the at the beginning, but then I heard about this, and I was more interested on the hands-on concrete, steel side. So then I was like, why not? So we actually ended up applying a lot of our knowledge that we gained from steel class, because we do take a steel class, and ended up applying it to this. We did ended up using a book that we did have to buy that looks like a Bible. Let me show it to you. This thing is huge. It's our steel book. So we used all the information from that book to be able to create that frame.
That's cool.
Yes, it's very interesting.
Yeah.
If you're still there around the 7th floor, maybe you might end up seeing this.
Yeah, I might see it
next semester. Yes.
Yeah.
Maybe you can check it out.
All right, thank you.
You're welcome.
Yeah.
Hi, Ruth. Ruth.
Hello, Ruth.
Are you there? We cannot hear you. Oh, you're.
Yeah.
She said hello through the message. You can't speak, girl. I know you. It's okay. Do you have any questions? You want me to do a quick overview for you again? Just for you. Hello?
No chat.
I don't know if she's there. I don't know if she's having issues with her connection. She's not messaging. Oh, it says, yes, please, an overview. I know nothing. Girl, well, I'll show you about structural analysis engineering.
Software that goes behind it.
This was a senior capstone project that was assigned to Danny and I. We had to calculate, we had to create a frame that will be able to withstand the load that was going to be added by a jack to test concrete beams. The only information that Dr. Tito gave us was it has to be 7 feet tall by 12 feet long. And he helped us out a little bit in the calculations to determine what type of steel to use on the frame. But we mostly use this big old book that we have right here. That's gonna be, oh, I don't know why it got blurry. Okay, but this giant Bible of ours for engineers to use for the calculations. With this frame, students are gonna be able to test deflection, strains,
Stresses.
shear, using sensors that are gonna be installed on the concrete beams. So it will be great for them to be able to apply whatever knowledge they're gaining from previous classes into this. They actually get to see it in person instead of just calculating numbers and not knowing how does it look like in like the actual like structures, you know? So it will be great for future students. We first designed this, we calculated it, we put it in RFM to make sure that it will be able to withstand the load capacity that's going to be applied to it, which is 10 tons or more, so it could work perfectly and not break down on students. From there, we applied the measurements into AutoCAD to show a drawing and be able to send those drawings to the shop that's known as Wellforce to help us create and make this frame actually be constructed. So here is here is a drawing on AutoCAD of the frame. And this is the RFM showing the stresses that are being applied into the frame, that will be applied to the frame. This is the final product. Right here, you can see this is just a small test. They had a small little beam that they wanted to test it on just to make sure it works. So far, so good. It looks very great. It looks wonderful. So this is how big it is. I'm 5 feet tall. Danny,
6'3".
yep. And you can see how humongous this is. It's around almost 2,300 pounds or more. I think it's like around 2,500. But the software gave us a total of 2,032 pounds.
Yeah, about 2030.
Yeah, but I think it might be a little bit more because we added the supports and we added this extra thing right here on the side.
Yeah.
But yeah, any questions, Ruth? Hello? I know, it was awesome. So awesome.
I know, right?
It was. Girl, you're driving and texting. You can't be doing that. Oh, you're in the, oh, with your family, but you're not driving, right? Don't tell me you're driving and texting. Okay. I was just wondering, did they hear about a project too? You should have had us on speaker. Oh, thank you. Yes.
Thanks.
Yeah, it was a lot of work, a lot of back and forth with the workers at the shop and my professor, and just up and down everywhere trying to figure this out and make it work. Oh wow.
That's one of those.
I understand.
Yeah.
All right, Ruth. Well, thank you so much for joining us here in our booth.
Yeah, thanks for joining us. Yeah.
Yes.
Mhm.
I know. I can't wait for it to be in school already. It should be at school already next week or before the semester ends. That frame should be at school already. All right. Bye,
Mhm.
Ruth.
All right, so
Thank you.
thank you. Yeah, if you're annoyed, that's just my mom in the kitchen.
Oh, it's okay. No worries.
Yeah, just be my mic until somebody shows up.
It's okay. I was worried about my dog. All right, so here you go. So this is a project, a senior capstone, our senior project that was assigned to me and Danny. We had to create and design a concrete testing frame that's 7 feet tall by 12 feet long. That's going to be used here at the university by future students. We designed this first with calculations, and then from that information, we were able to get the sizes of the frames that we will be using. the steel beams. And then we inputted that information into RFM to make sure that our frame was going to be able to withstand those 10 tons that we will be applying. And from there, that information, we went ahead and put our size of our frame into AutoCAD, and we sent it to the shop to be actually constructed. So we were overseeing the construction of our frame. And as you can see, hold on, sorry. This is our AutoCAD drawing that we made that was sent out to Wellforce fabricators to start making our frame. We did add, there's more drawings to this, but this is the only drawing we were able to put on our poster. This is what we did in RFN to be able to calculate the stresses on the frame when the load is going to be applied to whatever concrete beam is going to be tested on that frame. And then this is the final product. You can see we tested a small sample that they had there of like a steel beam, just to make sure this is working. This is where the jack is. The jack's maximum load is 10 tons. So we did make this frame to resist that load. It could be taken apart and it could be put back together depending on the height of whatever concrete beam they'll be testing. This bottom part can be adjustable. It could go up and down. That's why there's those holes right there. These little parts right here act as supports, and it could be adjustable too. It could be brought up or brought down, depending on the height of the concrete beam as well. This is just a quick view of how big this frame is. I'm actually 5 feet tall, and Danny is
6'3".
So you just imagine how big this frame is. But it'll be used by future students to be able to apply the knowledge they're going to be gaining from like the mechanics of material class into the frame by creating their own concrete beam and be able to test it there. They're going to be able to test strain, deflection, shear. So they're going to be able to see all of that while testing their concrete beam.
Well, that's nice. I got it's like a personal question. Like when you do project like this, so how you manage the budget is on you or the department?
I'm sorry?
When you, it's like more like a personal question. You know, this research, whatever you are doing. So when you're building this stuff, like how you manage the budget is all on you guys or the department?
We got a grant from the Hilberton professorship and the Department of Science, Computer Science and Engineering Technology.
Oh, okay, cool.
Program, yes. Any other questions?
So what's like the highest load that it can hold?
I think it's supposed to be double its.
Yeah, there's up to double. So I think the jack we have, it puts about 10,000 pounds of force. And the frame will be rated up to twice that. That'll be like about 20,000 pounds of force.
Okay.
Should be able to resist double the load that's going to be applied. But the maximum load that we are going to be using is that jack that is 10 tons. And we made it to withstand 20 tons, which is double the load of the jack.
Oh, that's cool. All right, guys. Thank you.
Thank you.
Good.